3 years ago, last year. All right, so we're going to do law of sines today. You do need a calculator. You may want your purple sheet because I'm not actually going to tell you what the formula is because it's on your purple sheet. I wanted to follow my mom. Oh, God, I'm recording. I can't. It's already started.
It's too late.
I don't. You only wanted to follow my mom on Instagram because you should. She was hot. Yeah. I can cut this part out of the video. All right, so we've got quite a bit of writing to start. Yes, we do have some stickers. All right, so if you have your stickers from the other day, you need the bottom two now. And if not, I have them. Do we need them? Okay. Well, that one printed all stupid. You got them, you got them, you got them. You don't? Okay. I saw stickers on the table. All right, so the two triangles that you guys see up here right now are not the two that you actually need to put the sticker on for. We good? We good? You need just the bottom two. All right, focus, child. You have to draw that in, yes. I'm trying to get to the stickers ahead of time. No. Finish writing. No. No mullets. No mullets, I'm recording. Let's go. All right, I'm scrolling. Jack? I was at least going to go past that part. You're going to need it here in a minute, yes. Not yet. Darn it, I lost the whole recording of a child coming in last period and asking for food. We will get you food. Yeah. You got the way wrong class.
Pardon?
You have the wrong class. This is 603.
Thank you.
Thanks. Okay, on that note, we're scrolling. Can I go past the picture? Oh, okay. I can at least give you the writing under it. So the triangles, the three triangles that you've got, there's actually two of them on the same sticker. You can just put them both on there. You can cut it and leave one of them. It does not matter to me. It's what little kids do. I got yelled at by my grandmother when I was like 4 for coloring outside of the lines. So I went and took my coloring book back to my mom and said, I'm not allowed to color anymore because Grandma said I color outside of the lines. My mom lost it. She was like, your coloring is beautiful. You keep doing what you're doing. And then like fought my grandma. And then in middle school it ended in middle school, but I ended up going and winning art shows all through elementary and middle school. Like this many. There's something about that, man. When you're little, like parents just, I'm 35. My mom still has all my drawings from when I was little. And all the ones from the art shows. Mhm. No, you don't get scissors. You can't be trusted. Yeah, it's two of the same ones on there. All right, so law of sines, we tend to really focus on using that when we're given, I call it a complete pair. So an angle and its matching side. Bless you. Anytime you're given all three sides or side angle side, which means you have an angle but not the side across from it, you end up using law of cosines, which I personally end up liking law of cosines a lot better. But law of sines is easy peasy too. And then we're going to start getting into the ambiguous case, but I'm going to pause it, and then I'll record the rest of it fifth period, where we get into the two possible solutions, just because there's a cute little video that makes it make sense. And I didn't bring stuff to make it make sense today, so it's easier that way. Yeah, my lunch. Yeah. Most of the time things don't blow up fifth period, so. All right, can I go past the law of sine stuff? Okay. Basically, case 2 is a pain in the butt. To the point where I made like a handy dandy little idiot's guide for it. He's cute. I need it every year. All right, so hold on to this. You don't need it until later. Should I give them the same boilerplate statement if thou shalt not eat the glue sticks?
Wait, what?
Don't eat the glue sticks. No, but someone also tried cutting their lip off with scissors. You almost succeeded. You know I'm never going to let you live that down, right?
Look, I used this, not this same method, but like literally the same exact notebook other than the color. All 1148. And it did not be
You were playing with scissors and the notebook got scared and started trying to run away. All right, so hold on to those little sheets. You don't need them quite yet. So, wait, what? Okay. No, you only needed one of them, not both of them. Yeah. You do have a minor candy addiction. I know, but if he gets a bunch of cavities, that's his parents' problem. I have to fill out. Don't hold the scissors by the sharp part. Take the scissors away. Claire, take them. You can't be trusted. Well, yeah, I mean, sugar is literally one of the most addictive substances on the face of the planet. What'd you say? Chicken? Anyway. Anytime we do triangles, I always do them the same way. A, B, C. They don't ever change. That's what I did. I gave Miller 2 of my Bosco sticks. I was like, here, you take the tray. And then I carried all of these applesauces back to the room. All right, so focus, children. Angle A is 40 degrees, which means the side directly across from it is side A. That's where you put the 4. I've always taught my kids to treat the angles like a spotlight, and they shine on their corresponding side. All right, little light shining this way. Ooh, it even gave me highlighter. Cool. Did not plan that. Angle B, 60. That's side B. Can I find angle C? How? How did you know it was 80? Minus complete sentences. Yes, I have 100 degrees here. There's 180 degrees in the triangle. That makes this 80. All right, and that makes this side C. Okie dokie. Cool. So, what do you guys notice about law of sines on the back of your purple sheet? Yeah, it's just 3 proportions, right? So anytime I'm using law of sines to solve, I always stick with the matching pair every time I set it up. So I've got sine of 40 over 4 equals, I'm going to solve for side B first. So I'm going to do that angle over B. All right, now I'm also lazy, so I want to figure out what can I enter in the calculator to make my life way easier and just do it in one swoop. So we cross multiply. B sine of 40 equals 4 sine of 60. Divide by sine of 40. What'd y'all get? What'd you get? 5.39? That's it. Now, does that answer make sense? Because if my angle's 40 and it gives me 4, if I go up to a 60-degree angle, side B should be larger. So it makes sense. I always just called those sanity checks, just to make sure I haven't completely snapped and lost my mind yet. Nope, not 60, 80. All right, now, have you guys noticed yet that this one and this one end up on top, and this one ends up on the bottom? Cool. We in agreement? Cool. Easy enough. Do you guys want to try another one? Yes, no? Okay. Then, Jack, how about you come up here and work it out? We'll give him a minute to start it. I'll pause this. Agreement? Yeah. Cool? Jack, here's your candy payment. I only gave him 2. We're fine. All right, so next sticker. We are dealing with the lovely mountain problem. And because it's Sullivan, and Sullivan's an idiot, he wrote that the transit is 2 meters off the ground. It's the surveyor. It's wrong in the book, too. I don't know. A surveyor is the person you see it on the freeway where they've got the little thing and they're measuring to another person to see, like, if land has moved up, moved down, like, or is it sinking in certain areas? It's a fun job with trig all the time. Let's be real. You know you want to do it. You want to be a surveyor. You get to be outside, play with a bunch of trig stuff. It's fun. Everyone's like, no. All right, so here is the picture for this. I have a mountain. We put the Grinch on it last period, so here's the Grinch. Should I break the Grinch for them too? Okay. The mountain has a height, goes directly down to the ground. I have my surveyor dude or dudette over here, and they are 6 meters, or 2 meters, 6 feet off the ground. When they're way out here and they look, they have an angle of incline at 35 degrees. He walks 900 meters closer to the mountain. They take another survey place. That gives me this angle here at 47. All right, so what they're really wanting is the height of the mountain. So we're going to use both law of sines in partiality, like we're only using part of it. And then we're going to be using regular right triangle trig. Because can you guys see, like if I cover the Grinch and the mountain up, I've got like just an oblique triangle, yes? If I cover up all the blue crap, I have a right triangle right here. Yes? So, we're going to be using both. Now the first thing I'm going to want to find is I'm going to want to find this length right here. Alright, the problem is I only have one angle inside of that blue triangle. Can I find the other two? Okay. What's the one next to the 47? 33? 133. Which means my top angle is, because if I can do that, I can solve for this height on the triangle with sine. The height of the mountain, yep. So, exterior angle theorem from geometry, because, you know, you wanted that brought back up, says that the two opposite angles add up to equaling that exterior angle. So if this one's 47 on the outside and I got 35, means that top one's just 12. All right. You're rich for forks. So when I start and I go to find x, I've got sine of 35 over x equals sine of 12 over the 900. Can you guys solve for that x real quick? Alright, so, since I'm in the business of ruining childhoods, if the Grinch lives at the top of the mountain, and do you guys remember the movie said the Grinch has been up there for like 20 plus years?
Yeah.
How did he get Max?
How do you get what?
How did he get Max, the dog? So, yeah. Max got put in the trash. That's how he gets everything at the top of the mountain. Is Whoville dumps all of the gifts they don't want in the trash, and that's how Max ended up there. Is that not messed up? See, now I'm just going to have to break all the classes. It is very wrong. Alright, so, now that we've kind of messed that whole thing up, over here, this is just sine of 47 equals opposite over hypotenuse. What is it? 18, 15, I think. $86. Are you guys in agreement on the 18, 15, 86? Yeah. All right. I gotta add the height of the surveyor, because that is excluded. So the real height of the mountain is 18, 17, 86. Yes, meters, so the science teachers don't eat me. Cool? Alright. I say we just keep going, because I won't be here Monday, and you guys are going to want to work all day, so we'll just knock it all out. Alright, ready to flip? I flip it a page. So, you guys are going to need to glue this on the ambiguous case. I make this fancy dancy little thing, because mainly I need it too. And because it's stupid, when you go to fill in, like A, B, and C, If this is angle 1, this is side 1. If this is angle 2, this is side 2. If this is angle 3, this is side 3. You're basically looking for what matching pairs do you have when it comes time to go through and make it. So the biggest thing you want to start with is what is the angle I was given. Now, if it's angle side-side or side-side angle, it doesn't matter. You can call each other that. You may not use the other word. All right. And if you're in stats, they call each other null hypotheses all the time. So, it's HO. Yep. So my first check is always what kind of angle do I have? Do I have acute or do I have obtuse? Now, do we remember what obtuse is? Yeah. Greater than 90. So greater than 90 degrees. Then we have a check to do if it's acute, and then we run through everything. So, we have 3 main examples, and then there's a word problem, but I will get the sticker printed for that later. We're only going to do the first 2 word problems because it's Friday and everyone's brains are mush. And then I can make a big long video of me actually explaining it without discussions of, you know, scissors cutting children and stuff like that. So, righty. She's pretty smart. Leading coefficients, degree. That was mine. Hang on. Let's finish these 2. Then we can squirrel. All right. So, I have side A, that's 2. I have side C, that's 1, and I have angle C, that's 50. So, when I go to write it, I've got side 1 equaling 1, and I've got angle 1, because that's its corresponding angle, at 50. Then I got my second side at 2. All right, so run me through my little, what are these things even called? I know they have a name. Flowchart? Follow the flowchart. Is it acute or obtuse? All right, so what is my next step? Do the thing, find the height. So, the H equals, height equals, ooh. Yeah, so the height equals side 2 times the sine of angle 1. So what was side 2? What is angle 1? So what is 2 times the sine of 50? All right, so what I tend to like to do from here is I like writing out, okay, side 1 is 1, and that is less than my height, which is 1.53, which is less than side 2, which is 2. I do this on purpose. Give me a second. Just write it. It makes sense, I promise. Wait. All right. Tell me when we got it written. We good? All right, so we've got on our lovely little thing the 4 things to check. Okay? So is side 1 less than my height? Yes. Side 1 is less than my height. Guess what? We're done. No solution. No. So the reason there's no solution is because if you were to actually draw this and make it to, like, spec, that's 1. Your side length across from that angle is not long enough to reach. Okay? So it's not even closed triangle. It's got a gap. Okie dokie. All right. Ready? Next example. Ready to draw a picture? Angle A is 40. Side A is 3. So, angle 1 is 40. Side 1 equals 3. Side 2 is 2. So far, so good? So, angle, acute or obtuse? Acute. All right, second step. Now I got to find the height. So remember, height is side 2, which still happens to be a 2, times the sine of 40. What do we end up getting? 1.28 or 1.29? All right, so I still like going through and rewriting everything. Are you sure it's 1.29? Okay. So I have h is less than side 2 is less than side 1 because it goes 1.29 is less than 2 is less than 3. All right, so we've got one solution. Side 1 is not less than the height. Oh, you stupid thing. Undo. All right, so this one's out. Height is not equal to the side. That one's out. We do not have h side 1, side 2. Instead, we have that side 1 is greater than side 2. But we don't know anything about the h. So, is side 1 greater than side 2? Yes, so we have one solution. Because this is the true bit. No, we're going to. I was going to say, we can if you want to. But if you guys are like, I know how to solve the stupid thing, just get me through the solutions, we don't have to. No. Do you guys want me to solve the rest, or do you want to do it? You can do it. The pair I've got is with A. So I'm going to go sine of 40 over 3 equals, now I'm going to start by solving for sine B over 2. All right, the reason I'm starting with that is just because I kind of, well, number 1, it's the only thing that I've got a piece for. But number 2, I don't know anything else. It's the only thing I can do. All right, so cross multiply. Let's solve. All right, what'd y'all end up getting for B? 20 what? Which means I can now solve for C. What do you guys get for that? 114.63? All right. And last step, I don't know why it just did a highlighter. I yield. Stupid thing. I would stick with using sine of 40 over 3 just because, number 1, I'm a little lazy, but number 2, I want to stick with the smallest numbers I can mess with. So, I've got sine of 114.663 over side C. We in agreement? Bueno. All right, I'll finish recording the rest. You guys have Mr. Lucas, as you saw, for Monday, so he's pretty chill. You'll have one problem that we'll keep working on. This is a 2-solution one. So I've actually got like a little GIF that I'm going to show you guys that makes this make sense. And then I've got a word problem one as well. So 5th or 6th period, I'm going to try and print this. So that way you guys have it to stick in your notes for Monday. Okie dokie.